trying to get by itself?
X.
X. The reason it's not by itself is because what's with it? A minus 4. Can I go ahead and add that 4 over? Why not, Maddie? Why not? Why can I not add the 4 over yet?
Because it's under square root.
Right. It's trapped up under the square root, and how do you tear down a square root? Square it. Okay, they're inverse operations, so they cancel each other out. Whatever you do to one side, you do to the other, so we have to square this side. So now on the left, we have 0 squared, which is 0, and on the right, we now just have x minus 4. The radical's gone because it got canceled out. Now we have an easy one-step equation. What do? Add 4 on both sides. And so 4 equals x, or x equals 4, however you want to say it. Okay? We always have to check it. So if I plug in a 4 right here, what is 4 minus 4? 0. What's the square root of 0? 0, so it works. So that's your solution. Alright, number 3. This time we're trying to solve for the variable v. But it's not by itself because it's being multiplied by 16, and they're both trapped up under a square root. So what do we need to do first? Square it, and if you square this side, you have to square this side. So now what do we have on the left? 16. And on the right, those cancel each other out, leaving just 16v. And now what do I do? Divide by 16, divide by 16, so v equals 1. Okay, now let's check it to make sure it works. If I plug in 1 in the v place, isn't that 16 times 1, which is 16? And isn't the square root of 16 really equal to 4? So it worked. That means you did it right. Alright, number 5. 4 equals the square root of v minus 4. What do I need to do first? Square it to get rid of that square root, and then I have to square this side. That becomes a 16, and over here it's just v minus 4 now. So now what do I do? Add 4, and so I get 20 equals v, or v equals 20, however you want to write it. Okay, now I check it. If I plug a 20 in right here, what's 20 minus 4? And what's the square root of 16? 4. So it works. So there's your solution. Number 7. This time we're trying to isolate the letter n. The only thing keeping n from being by itself is the fact that they're doing the square root of it. And you can undo that by what? Squaring it. And then whatever you do to one side, you have to do to the other. So the left side becomes a 16, and on the right side, those cancel each other out, leaving n, and isn't that the answer? And doesn't that make sense? Isn't the square root of 16 equal to 4? So you can pretty much look at 9 and tell me what b equals.
You got that right.
4. The square root of 4 equals 2. What? You can just plug it in. Plug in 4 for b. The square root of 4 equals 2. So 4 is the right answer. Okay, so those were kind of like yesterday. Some were even easier. Now we're moving into the new stuff. Can you already tell how it's going to be different? Right, it's equal to n instead of equal to a number. Okay, so you have a variable on both sides. So pay attention, and then I'll give you time to copy it once I've done all the steps. Okay, so just watch, and I'll give you time to copy it. Okay, you're trying to isolate the n. Well, this n is isolated, but this n is not. So we need to get this n by itself. Well, we can't really move the 7 away from it or the negative 6 away from it until the square root is gone. And we all know to get rid of a square root, you square it. And then you have to do it on this side. So now on the left side, you have n squared. On the right side, the square root and the squared cancel each other out, leaving negative 6 plus 7n. Okay, now we see that we have 3 different terms, and none of them can be combined, because this is an n squared, this is a constant, it doesn't have an n at all, and this is an n to the first power. So anytime you you end up with a situation like this where they can't be combined, you move them all to the same side. So if I want these to come over here with the n squared, how would I move the 7n over here? Subtract it over. So it would become minus 7n. And how would I move the negative 6 over? Add it. It would become plus 6. And then on the right, we now have nothing, so you put a 0. Okay, any questions about what I just did so far? I just moved everything to the same side since nothing can actually be combined. They're all three different types of terms. Well, now that I have them all on the same side, I have a trinomial that can be factored by the bubble method. Okay, and it's been a little while since you've done this, but you should definitely remember it. To get n squared, it's n times n. And then to get your numbers, you're looking for two numbers. And they have to add to negative 7, and they have to multiply to 6. Okay, negative 6 and negative 1 will work. Because a negative 6 times a negative 1 is a positive 6 when you multiply them, but when you add them, they add up to a negative 7. Okay, now the final step is you take this n minus 6 and set it equal to 0, and you take n minus 1 and set it equal to 0. Now to solve this one for n, what do we do on both sides? Add 6, and so you end up with one of your solutions is 6. To solve this one for n, what do you do on both sides? Add 1, and so your second solution is n equals 1. The reason you ended up with two solutions this time is because you ended up with an n squared, a quadratic, okay, which is two solutions. Yes, it will be. Like, yes. He said, will this number always be the opposite of what it was up here? And it will. So really, eventually, you'll stop writing this step. But I just did it so people understand why they're changing signs. Okay, so now let's check them, but we have to check both of them. Okay, so the first time we'll check 6. That means we put a 6 in this in place, and we put a 6 in this in place. Now in your calculator, type in the square root of negative 6 plus 7 times 6, and tell me what you get. You get 6. And isn't that what it says it will equal? So this one works. Okay, now let's try it with the 1. You replace both ends with a 1. So now in your calculator, you'll be typing in the square root of negative 6 plus 7 times 1 and see what you get. You get a 1, right? So that lets you know this one also works. Okay, once you have that copied, you can turn to the next page. Are we good to move on? Okay. Alright, number 13. We have b's on both sides. Well, this b is not by itself because it's multiplied by 5 and there's a square root over it. So what do we need to do first? Right. When we square it, it'll cancel out the square root, leaving just 5b. And when we square this side, we now have b squared. Okay, so for this one, we had two different terms that are not like terms. It's not like you can combine those. So you put them on the same side. How can I move this 5b over to the b squared? Subtract it, so it'll become minus 5b. And now we have nothing on this side. Okay, so now this one is a little different because you only have two terms. So for this one, you can factor by GCF. What do both of these terms have in common? A b, so you can factor out a b. Remember, when you're factoring out a number, you're dividing it out. So what's b squared divided by b? Okay, think about it. B, because look, b squared, isn't that b times b? And then 1b is just this, so look, it cancels out and you're left with a b. And then what's 5b divided by b? 5. Okay, so now just like we did last time, you would set each part equal to 0. So you would set the b equal to 0, and then you're done with that one, and you would set the b minus 5 to 0. And then to solve this one, what do you do to both sides? Add 5, so your second solution is b equals 5. Okay, so you have b equals 0, b equals 5. Let's check them both. If we plug in a 0 on both sides, what's 5 times 0? And what's the square root of 0? 0, so that one worked. If we plug in a 5 on both sides, you'll get 5 times 5, which is 25, and then isn't the square root of 25 equal to 5? So that one works. Now, let me show you one other thing, another way you could have done this. You don't have to erase your work. I'm just going to show you something in case you don't like factoring by GCF. When you get to this point, you could just, if you want to, since it's missing the constant, it only had the b squared and the b to the first, it didn't have a constant, you could fill it with a 0, and then you could factor it by the bubble method, like we did in the previous problem. And so now you need a b times b, and you're looking for two numbers that do what? Add up to -5 and multiply to 0. So what numbers will multiply to give you a 0 and add to give you a -5? A 0 and a -5. Well then look, and that's just going to give you a b equals 0 and a b equals +5. So if you don't like to factor by GCF, you could just throw in a 0 in the C place and make it a trinomial and do the bubble method. It's up to you, whatever you like better. Okay, are we good to move to the next one? Okay, number 15. What should I do first? Right, I need to get rid of that square root, so I square it, and it will cancel it out. If you square this side, you must square this side. So now I have b squared equals -54 plus 15b. None of those terms can be combined. They're all different. That one's b squared. That one doesn't have a b at all, so it's constant. And this one is b to the first power. So anytime you're dealing with three different terms, what do you have to do? Everybody remembers what we got to do? Well, not yet. What do we
have to move them all to the same side.
Right. We got to move them all to the same side, and you need to move them to the b squared. Because you always want your squared term to be positive so that it's easy to factor. So if I move these over here, it'll become what? -15b plus 54 and then equals 0. I just moved them over, and when you move something across the equal sign, it just changes its sign. The 15b became -15b. The -54 became +54. Right. Now I'm ready to factor this by the bubble method. Okay, to get a b squared, I need a b times b. And then I'm looking for two numbers that will do what? Right, add to -15, multiply to 54. What are some numbers that multiply to 54? 6 and 9. Will 6 and 9 add up to a 15? But they both need to be negative, so they'll make a -15. And that's okay that they're both negative because they'll still multiply to make a +54. Because a negative times a negative is a positive. So now remember, you set each factor to 0. And like I said, eventually you'll start skipping this step. And now you just solve each one. To solve this one for b, what do you do to both sides? Add 6, add add 6, and so one of your solutions is positive 6. And to solve this one for b, what do you do to both sides? Add 9, so b equals 9. Okay, so now you have two different solutions to check. So first we'll start with 6. If I plug in a 6 right here and a 6 right here, type in the square root of negative 54 plus 15 times 6 and see what you get. Okay, what did you get when you type that in? 6, and that's what we should get because we filled in a 6 for that v as well. So that one's good. Now type in 9. Put a 9 in put a 9 in both v places, and then type in the right side and see what you get when you hit equals or enter. Okay, what did you get when you typed it in? 9, so both of those work. Okay, are you ready to try one on your own? Okay, try 17 before I go over it. Just put that red notebook in the crack when you get it open. Number 17. The first thing we have to do is get rid of the square root because everything's trapped up under it on this side. So to do that, I square. They cancel each other out. Then I square this side. That becomes n squared equals 14 minus 5n. Now, since all three of these terms are different types of terms and can't be combined, you move them all to the same side. So I'm going to add the 5n over, and I'm going to subtract the 14 over. So now I'm looking for two numbers, and those two numbers need to add up to a positive 5, but multiply to a negative 14. What numbers will do that? Positive 7 and negative 2, right? Because 7, look, 7 minus 2 is positive 5, and 7 times negative 2 is negative 14. If you had put the negative on the 7 and the positive on the 2, that would have made a negative 5 when you add them. Now, for the next step, you are going to set each one of those to 0, which will then just do what? Change their signs. So this one ends up equaling negative 7, and this one ends up equaling positive 2. Yes. Okay, but now let's check these. In your calculator, go ahead and plug in negative 7 for both end places. Well, you obviously don't plug it in this one, but plug in a negative 7 right there and type that in. Okay, when you type in a negative 7 and hit enter into that side, what do you get? So that one didn't work out, did it? That's what we call an extraneous solution. So on your test, this is not going to be one of the right answers. It might be there as a choice, or like they might give both of those by letter B or letter A or whatever, but this is not right. Now let's check 2 as a solution. Okay, if I plug in a 2 right here and a 2 right here, type in this side and see what you get when you hit enter. You get positive 2, so that is a solution. So like on the test, if you had A, B, C, D, and you have like like n equals 7, n equals 2, n equals negative 7, n equals 2, n equals 2, n equals negative 2. Which one is the right answer? B, right? The one that says n equals positive 2. That's the right answer on the test. Even though you got negative 7 and you did everything correctly, it's known as an extraneous solution, and so you will not use it. Okay, C would be wrong, because this should not be there, it was extraneous. An extraneous solution is a solution such that as that to an equation that emerges from the process of solving the problem but is not a valid solution to the original problem. All right, number 19. Now, number 19, what do I need to do first? Square it, okay, and it'll cancel out that square root, and then I'll square this side. So now I'll have negative 24 plus 11b equals b squared. Now remember, even though, yes, it seems like it would be easier to just move b squared over instead of having to move two things over, we don't want our b to ever, we don't want our squared term to ever become negative. So that's why we move everything to it. So what do we move to it first? The 11b. When you move the 11b over, how do you move it over? Subtract it over, because it was positive. So now it's gone, and now it's minus 11b. To move the 24 over, how do we move it over? Add it. So now it's positive 24. Now we have a trinomial that we can factor into two binomials using the bubble method. B times b will give you the b squared. And what are our numbers that multiply to 24 and add to negative 11? Negative 8 and negative 3. And so now, what do you know your final solutions will be? Positive 8 and positive 3. The opposite of what's in there. Okay, so now check them both. Plug in 8 into both b places and make sure it works, and plug in 3 into both. When you type in 8 in all of this, you should get 8. When you type in 3 in all of this, you should get 3. Okay, so go ahead and type them in. One of them are extraneous. Okay, number 21. What should I do first? Square it. Okay, to cancel out the square root, but if you square this side, you got to square this side. So now I have 8 plus 7n equals n squared. So now what should I do? Right, move 7n to the other side by subtracting it, and then move the positive 8 by subtracting it, right? Now everything is on the same side, with the n squared. And for it to move over there, it just had to change its sign, right? Now we can factor that by looking for two numbers that do what? Right, but multiply to negative 8 and add to negative 7. So what are some numbers that multiply to 8? 8 and 1, and yes, to make them add up to a negative 7, this needs to be a negative 8, that needs to be a positive 1. So then your final solutions would be what and what? 8 and negative 1. Now check each one of those in the original equation to see if both of them are real or if any of them are extraneous. To this one is the positive 8. This is considered an extraneous solution, and so you would not choose it on the test. You would only choose the choice that just had n equals 8, or whatever equals 8. And think about it, it's because you're never going to square root something and get a negative out of it. Okay, it's not possible. Okay, number 23. Well, not today. This was harder than yesterday. Okay, what should I do first? Square it, and then that means I square this side. Those cancel out, and so now I have x squared equals negative 32 plus 12x. Okay, so now when I move everything to the same side and set it equal to 0, what will the trinomial look like? move everything over with the x squared. You just change its sign, and put it on the side with the x squared. So now we can factor by the bubble method, and we're looking for two numbers that do what? Right, multiply to 32, add up to negative 12. What two numbers will do that? Correct, 8 and 4, but both need to be negative so that they'll add up to negative 12. And then it's okay that they're both negative because when you multiply them, it'll still be a positive 32. And so that means the actual solutions are what and what? Positive 8 and positive 4. Now take a second to check each of them to see if both of them are good or if any of them are extraneous. And then you type in 4 into both x places. So the square root of negative 32 plus 12 times 4 equals 4. So that was good. Neither one of them were extraneous. So on the test, you'd be looking for the choice that had both of those numbers. Okay, quickly try number 25 by yourself, and then I'll assign your homework. The first thing you do is square it so that you can cancel out the square root, and that means you have to square this side. That leaves you with negative 10 plus 7x on the left side and then x squared on the right. When you rewrite it so that everything's on the same side, what will it look like? Correct. And now when you factor it, you're looking for two numbers that do what? Okay, what numbers will that be? Right, negative 5 and negative 2, because they'll add up to a negative 7, but they'll multiply to a positive 10. So your actual solutions are what and what? Positive 5, positive 2. Okay, now let's quickly check them to make sure we don't have extraneous. So first I'll plug in 5. The square root of negative 10 plus 7 times 5 equals 5. So that will work. The square root of negative 10 plus 7 times 2 gives me 2. So that one worked. No extraneous there. They both work. Okay, your homework on this page, page 14, you're going to do the top 3 questions, 14, 16, and 18. Yeah, you can. Just try it. Just try it. I know, you can do it. There's ones beside both of those x's. Okay, and then on the previous page, you're doing 2, 4, and 6. So just the top right 3 on each of those pages, 13 and 14. That's only 6 homework problems. Go ahead and write it on your pink sheet. Once you've written it on your pink sheet, you can switch out. 2, 4, 6, and 14, 16, 18.